Hi, and welcome to our next edition of our naming of functional groups. Today, the functional group that we are going to look at are our aldehydes and our ketones. So if you remember back to our syllabus outcome, it says to be able to name our C1 through to C8 carbons, including simple ethyl and methyl branched chains. And today we're going to look at the functional group called aldehydes and ketones. So these two are often grouped together in the same kind of category because they share a commonality between the two of them, and that is that double bond O. So if you look in the formula or the structural formula that we have below, you can see two very similar groups here. And you can see here we have a C double bond O, and here again the C double bond O here. So what's the difference between the two of them? The difference between the two of them is that one has to be on the end carbon. So that's with our aldehyde. Our aldehyde is required to be on the end carbon, so it can be either on either end, whereas our ketone has to be on an inside carbon. So they share the carbonyl group, that is the name given to that double bond O, which is a carbon-oxygen double bond. But where they are different is their position. Now, when we look at our aldehydes, we've already said that the functional group has to be on the end. That's where it's located, so it's always going to be given the number 1. So that in that regard, we don't need to say that it is 1 butanol, because for it to be a butanol in itself, it has to be on that terminal carbon. Now, the name aldehyde is the group given, but it's more common or more correct IUPAC name is the alkanal group, and that is where we take it with our naming of those as well. So in this example that we've got here, we've got a simple 1 carbon. So of course we're looking with our prefix. 1 carbon is our meth group. So we have got a meth group. It's a methane group, so it's methane. And looking at the C double bond O on a terminal carbon, it's a methanol group. So let's have a look at one a little bit more complex. So looking at this one here, again, we want to name our longest carbon chain. So counting through there, we have 1, 2, 3, 4. So it's a 4 carbon chain. That puts it at the but. We're looking again, there's no butene or butane, so it's a butane. So it's a butane, and then the C double bond O is on the end, so it's a butanol. Let's have a look at another one here. Again, the first thing we're going to look at, as we have done with all our other namings, is we're going to look at our longest chain. So again, here we look 1, 2, 3, 4, 5. So we've got our longest chain is 5 carbon chain. So we're looking at a pent group. Again, they are all single bonds, so it's a pentane group. Again, our C double bond O is on the end, so it's a pentanal group. And then we have here our methyl group. Now we name with the carbonyl group as being the lowest, so this will be our C1 here. So 1, 2, 3, it's a 3-methyl pentanal. Let's try another one. Having a look here, we have a 6 carbon chain. So we're looking at a hex group. Again, as I've said before, we have a double bond there. So we're now looking at a hexene group. Our double bond O over this way is on our end. So that makes it an al group. So we've got our hexene al. And then we name, the number is not on where our carbonyl group is, because it needs to be on the end for it to be an aldehyde and hence an al, but more about the position of this double bond, again numbering from the end where it will make the carbonyl group the lowest possible number there. So just to mix things up and make them just a little bit more tricky, we've got now here a 7 a 7 carbon chain, but we've now got a triple bond in there. So we're going to be now looking at a hept group for the 7, an ine for the triple bond. Our carbonyl group is over here on the end, making it an al, so heptine al. But where is that triple bond in relation to the carbonyl group? And it's on carbon 3. Now looking at our ketones, again, very, very similar to our alkanol groups. The ketones are ending, instead of al, they are ending in -one. So the C double bond O can't be located on the terminal or end carbons, otherwise it would make it an alkanal. So it is one of our inside carbon groups. The first thing we're going to do is give our carbon chain, so calculate our carbon chain. So if we have a look, we have got 1, 2, 3, 4, 5, 6, 7, or even if we went the other way, 1, 2, 3, 4, 5, 6, 7. So it's a hept group. I can see that there is a double bond here, so it's a heptene group. The presence of this C double bond O here tells you that its suffix is an -one, so we're looking at a heptene -one. Now, where is the location of that? So we need to look at the position there of that double bond. So if we come from this side, 1, 2, 3, 4, it's located, this is located at 4. If we come from this side, 1, 2, 3, 4. So our ketone group is on carbon 4, which is why we have heptene 4-one. So that's the position of the carbonyl group. We now need to number our ene group. Again, we're always wanting our numbers to be the lowest possible combination. So regardless of what side we come in for the carbonyl group, it is a number 4. So if we number from this side, this will give us the 2 as the lower number rather than coming from the other side. So we've got the 2 is for our 2-heptene, saying the position of the double bond. And then again, numbering from this side, 1, 2, 3, 4, 5, 6, we have our methyl group there. So that one is a little bit tricky as your first introduction to those. What we're going to do is try a lot of these in class, and you'll be naming them like a pro in no time. See you soon.